In this video, we'll talk about benzene derivatives, and we've certainly talked a lot about benzene already. We know that there is a cyclic arrangement of p orbitals, it's a planar molecule, it's aromatic. It's also the base, and this structure is the base of a lot of very common and important molecules that are found in nature. This six-membered ring with the alternating double bonds. And so in this video, we're going to talk about how we name benzene derivatives. So if we have that benzene structure, but another atom or group of atoms coming off of that benzene ring, how do we name those molecules? And so we'll start off with just having one substituent on benzene. So if we have one substituent, I'll draw out a couple of examples. Let's say we have our benzene ring and just one chlorine atom. This molecule would be named chlorobenzene. So we use benzene, that word, as the parent name for these molecules. So there's chlorobenzene. Here is another one. This benzene ring has a substituent of NO2. Now this substituent, NO2, is called a nitro group, and that's a good one to commit to memory. And so if this is called a nitro group, nitro substituent, then this molecule is nitrobenzene. Here's one more example with a substituent that you should recognize. This is an ethyl group, so this is ethylbenzene. There are also some benzene derivatives that have common names, and so we'll want to remember these as well. These are benzene derivatives with one substituent. Here's an example for this first one. So if we just have a methyl group as a substituent on benzene, the IUPAC name would be methylbenzene, but the common name is toluene. And so that toluene is actually used in names when we're talking about benzene derivatives. So these are names that you also want to commit to memory. So we have toluene. If that substituent is a hydroxy group or an alcohol, we call this phenol. And then if that group is an amine, an NH2 group, primary amine, this is aniline. So we have 6 structures on the screen right now. The first 3 are IUPAC names for benzene with one substituent. And the second 3, the bottom 3, are common names of different benzene derivatives. And all of these just have one substituent. We'll, of course, do some examples in class. But let's move on to when we have 2 substituents. When we have two substituents on benzene, we use words to describe the relationship of the two substituents as far as where they are positioned around the ring. So there are three prefixes that we'll use: ortho, meta, and para. So let's say we have a group. It can be any group. We'll just call this R. And that's one of the two substituents on benzene. If the other substituent is on the adjacent carbon to that R group or to whatever group is on the ring, we call that the ortho position. So that carbon would be ortho, and the carbon to the left would be ortho. If we have substituent R and the other substituent is 2 carbons away, so where I've drawn those pink lines, those are in a meta relationship. And then lastly, if the group is directly opposite of the other group, then this is para. And so those words become part of the name of the benzene derivative. So let's do 3 examples. I'll draw all of the molecules first, and then we'll name them together. Actually, we'll have to do, so these are the 2, and we'll do these 2, and then we'll do the third one, just because I can't show everything on the screen at the same time. So in the first molecule, the bromine and the nitro group, those 2 groups are adjacent to each other. They're on adjacent carbons. So these 2 substituents have the ortho relationship. So that means that name starts with either just an O, or you can write out ortho. I'll just keep it as just an O. And then since bromine and nitro either one doesn't have priority over the other, we pick the first alphabetical to name first. So this would be ortho, bromo, nitro, benzene. So that's how the ortho prefix comes into play for these molecules that have a benzene ring with 2 substituents. Now, it's possible to also see numbers. You might see that on different sites or different resources. And so in this case, you would give the substituent that comes first alphabetically the lower number. So this would be 1 bromo, 2 nitro, benzene. This next molecule, the bromine and the nitro group are in a meta relationship. So the name looks almost exactly the same as the previous one, but instead of the O at the front of the name, we have an M. So it's M, or meta bromo nitrobenzene. If we were to use numbers, it'd be 1 bromo, 3 nitrobenzene. All right, let's do another example. We'll still be working with bromo and nitro groups, but we will situate them opposite each other on the ring. So if we have bromo and a nitro group, these now have a para relationship. So as you probably guessed, we use a P for para. So we have para, bromo, nitro, benzene. And then if we're using numbers, this is now 1 bromo, 4 nitrobenzene. Now let's say you have 2 substituents, but one of them, I'm going to scroll up a little bit, one of them is a methyl group, an alcohol, or an NH2 group. In those cases, you will use the toluene word or the phenol or the aniline as part of the name. So we call those common derivatives. Let's say we have a bromine and a CH3. These have the ortho relationship. They're on adjacent carbons. And we have the CH3 group, which is a toluene. So this is a toluene derivative. So we say we have ortho bromo toluene. Or if you're using numbers, 2 bromo toluene. Now let's look at examples where we have 3 or more substituents. And once we get to 3 substituents or any additional substituents, we use numbers to indicate the position around the ring. So here's an example. Our benzene ring, let's say we have 2 fluorines and a chlorine. Oh, here we go. As you're naming these benzene derivatives, the first goal is to minimize numbers. So you want to use the lowest numbers possible. You give the lowest number on a parent group, so that's a common name, the CH3, OH, or NH2, toluene, phenol, or aniline. So you'd give the lowest number to that group if there is one. We call that the parent group. If there is no parent group, put the lowest number on the substituent that comes first alphabetically, just like we did above. In the molecule that I've drawn to the left here, we don't have a CH3OH or NH2 group, so we don't have a parent group. To minimize numbers, we can either have number carbon 1, 2, and 3 in this direction, or the other direction, where the chlorine is on carbon 1, and we have 2 and 3 there. Chlorine comes before fluorine alphabetically. C comes before F in the alphabet. And so the correct numbering for this molecule is to give that chlorine carbon number 1. So this molecule is 1-chloro, 2,3-difluoro, benzene. Let's do another example with 3 substituents. All right, on this molecule, we have an NH2 group. Now, this was one of those common groups, so this is aniline. We have a bromo group, and then over here, this is a methoxy group. To minimize numbers, and we know we want to give the lowest number to the parent group, we will have carbon 1 right there. Carbon 2 is where bromine is bonded. Nothing on carbon 3, and then methoxy is bonded to carbon 4. And then when we write the name out, we order substituents alphabetically, and we use that parent name aniline as the suffix of the name instead of benzene. So we'll start with bromo. We have 2-bromo. Then our other substituent is methoxy, so 4-methoxy. Aniline. So when you're drawing out these molecules, let's say you're given a name, you can look at the end here, see if that is benzene, see if it's aniline, see if it's toluene. That's where you're going to start. And then you add the substituents onto whatever that suffix tells you is part of the molecule. Now, sometimes a benzene type ring will be bonded to some larger molecule, and the benzene won't be the highest priority group, or the aniline won't be the highest priority group. An example of that is if we have benzenes as part of an ether molecule. And when that's the case, we actually use the word phenyl, P-H-E-N-Y-L, to describe that benzene ring, or to name that benzene ring. So this is when we have benzene as a substituent. We use the phenyl name. Sometimes this is abbreviated as C6H5, because that's what the substituent has as far as atoms go. So an example here is diphenyl ether. Remember, an ether is an R group bonded to an oxygen bonded to another R group, where those are carbon chains. So a diphenyl ether is an oxygen bonded to two phenyl groups, which is the C6H5 ring, 6-membered ring with alternating double bonds.